All right, let's get straight into it. Today, we're going to crack the code on a classic AQA GCSE higher tier physics question. The goal is simple. We're going to see exactly how you can bag full marks by thinking just like an examiner. It's all about mastering that official mark scheme. So, let's dive in.
So right off the bat, the question hits you with this really cool puzzle. Is light a wave, or is it a stream of particles? I mean, which one is it? Well, physics tells us it can be described as both. These are two completely different scientific models, and the exam is really testing how well you understand what that actually means.
So, first things first. Before we can get into the heavy stuff, we've got to nail down the basics. This first part of the question is all about defining our terms. What exactly is a scientific model anyway?
And here it is, question 09.1, pulled right from the exam paper. It asks, which statement describes a scientific model? Now, you're about to see 3 different options. Have a quick think. Which one would you go for? Because honestly, these 1-mark questions, they all add up to build that top grade.
And there you have it. It's the third one. Now, what's really interesting here is the super specific language. A scientific model isn't just a guess, and it's not just a tiny little version of something. Nope. The mark scheme is crystal clear. The correct answer is an idea used to explain observations and data. That level of precision is exactly what we need.
Let's really lock this definition in our heads. The crucial thing to remember is that a scientific model is a tool we use for explaining things, and it's built on evidence. It's the framework scientists build to make sense of the world. Using that exact phrase from the mark scheme is, without a doubt, the surest way to get the mark.
Okay, so if models are our best explanation for how things work, why don't they just, last forever? Let's move on to the next part of the question. This is all about getting why science is this constantly evolving thing.
This is the next logical step, right? If we have a perfectly good model for light, like the wave model, why on earth would we ever need another one, like the particle model? The good news is, the mark scheme actually gives you a few different ways to answer this and still get the points.
And here is exactly what the examiner is looking for. The key, the absolute #1 thing, is new evidence. So, you could say that new data is found that the old model just can't explain. Or you could just state that the old model is shown to be wrong. A new model only gets accepted if it can explain all the old observations and this new evidence. Any one of those points will get you the mark.
Now for the really fun part. The exam asks us to actually apply one of these models to explain something we can see in the real world. We're going to use the wave model to explain refraction. How does it explain light bending when it passes from air into a glass block, for instance?
Okay, this is a big one. It's worth multiple marks. This means it needs a clear, logical, step-by-step explanation. Just saying, the light bends, isn't going to cut it, not even close. We have to use the language of the wave model to explain why it bends.
So, here's the play-by-play for getting full marks. Step 1, the wave speed changes. It slows right down when it hits that denser medium. Now, step 2 is the really crucial part. The edge of the wave that hits the new medium first is the part that slows down first. But get this, the rest of the wave is still in the original medium, still going at that higher speed. It's this difference in speed across the wave that literally forces it to pivot and change direction. You explain that chain of events, that cause and effect, and you have absolutely nailed the answer.
So let's just quickly recap the key to all of this. Getting top marks on this question wasn't just about knowing the physics, was it? It was about communicating it perfectly, using the exact language from the mark scheme as our guide.
And honestly, this is the most important takeaway from this whole thing. To get the marks, you have to use the language of the mark scheme. Using those key terms like model, new evidence, and difference in speed, they aren't just buzzwords. They're the building blocks of a perfect answer, the things that show the examiner you deeply understand the concepts.
And that brings us full circle, right back to where we started. We can now define a model, we can explain why models change, and we can even use the wave model to explain refraction. But that big question is still just hanging there, isn't it? If light can be a wave and a particle, which one is it really? Well, that's a puzzle that continues to fascinate physicists to this day. Thanks for joining me for this one.